Good afternoon, everyone. In this video, we'll be talking about use case relationships. Okay, so what are the different types of use case relationships we'll be discussing about? Okay, so specifically we'll be talking about include relationship, okay, external relationship, and generalization. Independent use cases are sufficient for simple applications. For most of the simple applications, like independent use cases are already sufficient. In the last videos, we have already talked about use cases in detail and also the use case diagrams. But it is actually helpful to structure use cases for larger applications. Okay, whenever you are thinking in terms of larger applications, we need to consider this sort of structuring of use cases. Okay, so basically, the complex use cases can be built from smaller pieces with these use case relationships. Okay, so they include extend and generalization relationships. Let us look at them in detail. First, let us look at include relationship. The include relationship actually incorporates one use case within the behavior sequence of another use case. Okay, so when we were discussing about the use case, we were talking about the behavior sequence. Okay, so the messages which actually happen. Okay, whenever we were thinking about say for example buying the beverage, we were inserting the coins, and then there were certain steps. Okay, so that procedure is repeated, and then blah blah blah. Okay, so we have seen the behavioral sequence at that time, particular time. Basically, with include relationship, what you can do is you can actually incorporate another use case within the behavior sequence of one use case. Okay, so it is more or less included use case is like a subroutine. Okay, represents behavior that would otherwise have to be described repeatedly. Okay, I will give you an example, then that will make the things clear for you. Okay, so think about there is a stock purchasing application or whatever it is. Okay, stock broker application. Okay, so as part of that one, say for example, it's a web-based application. Okay, so you need to basically log into the system, and then you have to make the trade for it. Okay, for having this sort of secure session, say for example, it validates for the password of the user. Okay, and at the same time, for every trade that it actually makes, it also again has to validate the password. Okay, so then basically if either you can actually add all the functionality into one use case. Okay, rather what the include relationship is saying is within this secure session. Okay, so you can include this validate password. Similarly, in the make trade, you can actually include this validate password. So this is the UML representation for this one. This is the annotation. Okay, so the include annotation you will put on this sort of dashed line. Okay, for this include relationship. So now whenever you are implementing the system for the securing the session, you will have the validation password which will be inserted at that particular position. Okay, similarly make trading, you will be including the validate password. Similarly, we can think of another example. Okay, say for example you are in a hotel, you want to check out. Okay, so this is for the hotel management system. So a customer is there and he is trying to check out. The checking out actually includes you have to pay the bill. Okay, so you are checking out, so you have to pay the bill, and then you have to submit the room key. Okay, so both of them are the individual use case of their own, and then you can actually include them within this sort of checkout. Okay, so now hope the things are clear for you. So as far as the include use cases are concerned, they may or may not be usable on their own. Okay, so that is something which we need to remember. Yeah. That's about the include relationship. Then the second type of the relationship is this extend relationship. The extend relationship adds actually incremental behavior to a use case. Okay, so this actually represents the frequent situation in which some initial capacity is originally defined and later features are added modularly. Okay, so this is the general behavior. Okay, so we will try to implement something and then we keep on adding more features to it. Okay, in that sense, both include and extend add additional behavior to a base use case. Okay, so let's look at this extend relationship with an example, then you will actually understand it better. So for example, this is a library management system. Okay, in the first example, say for example here the person is borrowing a book. Okay, so borrow copy of a book. Okay, so that's the use case which you try to define in the system in this sort of library management system. Okay, so the book borrower, as an actor, he can actually invoke that use case. But the thing is, like, say for example, like if the book borrower has already certain number of books with him, and then like say for example, like he has not written the previous books which he was supposed to written by now, or else like he has to pay a huge fine. Okay, all those things. So basically, like in certain cases, like the borrow copy of a book, that can be actually refused. Okay, so a refused loan use case is an extension, okay, to this borrow copy of a book. Okay, so this is by extend relationship. So this is the UML representation, again like a dashed line with this sort of extend annotation. Okay, so this is the additional behavior which is actually added to this sort of borrow copy of a book. Okay, refuse loan. Okay, originally it was not part of it, but then like now it is. Okay, now similarly think about this situation, like there are trading the stocks. Okay, stock trading. So in the earlier stockbroker application, okay, so I was talking about. So in this one, like you can actually trade for the stocks. Okay, and then like say for example, you can add, this is the original use case, you can add additional functionality to that one. Okay, by adding this sort of margin trading. So of course, like I'm not an expert in trading stocks, okay, but the basic idea is like you trade the stocks means like if you have the stocks with you, okay, so you will be selling them, or else like you will be buying them when you have the money with you, okay, enough money with you. But then like there are extensions, like say for example margin trading. Say for example you don't have enough money, but then like you will be doing margin trading. So basically you will think like, okay, so I will promise like I will buy the stock, okay, and then like I will eventually be selling the stock. My idea is like I will make a profit out of it, okay, and based on that one I am already buying it. Okay, so as a loan I am buying it. That's the margin trade. Okay, so that's an extension to the basic trading the stocks. Okay, so that is one extension, extend a relationship. Okay, so this is a use case, okay, which actually is an extension to this one, okay, to trade stocks. Similarly, like there can also be a short sale. In this case, like you don't even have the stock with you, but then like you are trying to sell them. Okay, assuming like its value will be reducing, so that like later you will basically buy those stocks, and then like you will basically cover it up. Okay, cover the difference. Okay, so this is again another sort of extension feature for that one. Okay, so these are examples of extend relationship. The extended relationship actually connects an extension use case to a base use case. That's what I have given you the example. Here it is an interesting thing. The extension use case is often a fragment. It will not contain the full behavior. Okay, so it cannot appear alone as a behavior sequence on its own. Okay, you always need this sort of base use case. You always need this sort of base use case. Okay, whether you are doing any extension or not. Okay, so it cannot exist on its own. Okay, so the base use case, however, must be a valid use case in the absence of any extensions. Okay, so that's another very important point which we need to remember. Whether extensions, okay, extensions cannot exist on their own, that is clear from the previous statement. But the thing is, like base use case, even without any extensions, it should still be a valid use case. Okay, the extend relationship can specify an insert location within the behavior sequence of the base use case. So you can actually specify like when this extension, basically extension use case should appear. Okay, you can actually specify that function. Usually that location can be a single step in the base sequence, okay, of the original base use case behavior sequence, or in a range of steps. Okay, so during these steps, like it has to basically do this one. Okay, so I will give you the example, then you will understand it. Okay, so these are actually called like extension points. Okay, so let's go to this hotel management system. So a customer is coming and he is trying to reserve the room. Okay, so the reservation of the room, like he has to make certain steps, and that is why like that is the use case. Okay, but once he has done this one, like say for example, he can also do additional requests. Okay, so that is the extension point. So while he is reserving, of course, after reserving a room, after the basic steps before this use case is actually finished, that is the extension behavior which we are actually trying to add into the system. The external behavior is like request coffee machine. You actually reserve the room and then like you actually request the coffee machine, everything within this particular use case, in this base use case. The external behavior basically adds additional functionality to that, as the way like we have discussed, the modular functions are actually added. So the extension points actually specify when the extended use case has to be used, and then like at which particular place of the behavior sequence of the base use case, in this case like reserve row. Okay, hope that is clear. The third type of relationship is the generalization. This actually shows like specific variations on a general use case. So we had these sort of general use cases, we can have some sort of specific variations for that one. Okay, so think about this situation. Here is an example. We can place an order. Okay, say for example there is an online system itself, I mean like okay, so there is a hotel is there, I mean like there is a restaurant. Okay, so you want to place an order. Okay, so the order can be, you can directly place it because that's why like it's a use case, proper use case, place an order. And then like there can be generalization relationship, so where like these are specific variations of that particular placing order itself. Say for example if a customer comes and orders at the restaurant through a phone, so it is a phone based order. Okay, so it will have its own specific use case. Okay, so which is basically a generalized relationship with this sort of place order use case, the original one. Just like the way like we have seen with the classes. Okay, so this is the base class. Okay, the super class, and these are subclasses. Okay, the same way like we have this basic behavior. Okay, so we have this sort of generalized behavior. Okay, more generalized behavior, and then like you are adding uh, very specific variations for that one, more specialized. Okay, use case in this particular example, it is for the phone based order. Similarly you can have for an internet order, there can be an internet customer who can actually make use of this use case internet order. Okay, which is also has a generalization relationship with this sort of place order. Interestingly, a child can be substituted for its parent whenever necessary. So whenever there is an internet customer, he is actually using this internet order. Okay, this use case. Similarly, the customer is actually, whenever he is making the phone call, okay, he is using the phone order. Assume like if there is another customer who has directly come to the restaurant, he will still make the place order directly. Okay, so in that sense, like a child can be substituted for its parent whenever necessary. Okay, so that's about the generalization relationship. Whenever you are basically trying to draw a use case diagram, you can actually use all the things together. Okay, it doesn't mean like you only have this sort of include relationships or like extend relationships or only generalizations. Okay, within a single use case diagram, like you can incorporate all the things together. Okay, now let us try to look at an example, which is like we are trying to design for a clinic. Okay, so hospital. Okay, more or less. So let us try to put all these sort of use case diagram things together, okay, along with the example. See this one. Here is the system name, which is the clinic, which you will be putting, okay, as the system boundary, okay, as the system boundary for that one. We already have discussed like actors are always outside the system boundary, okay, whichever you are trying to develop, okay. In this one, like say for example, the system is clinic, okay, and then like the actors are the patients, okay, so the doctor and the scheduler, I mean like say for example a receptionist or someone, okay, so who will make the appointment for you. Okay, and then like there could be a clerk who will be actually collecting the bills from you. These are the external outside the system, so they are the actors. Okay, now think about this case. You can have several use cases. Okay, so it has this sort of, you can make an appointment. Okay, the patient can make an appointment. Of course, the scheduler can also make an appointment. Okay, I mean, like say for example, the patient has called the scheduler and the scheduler is actually making the appointment for you. Okay, so both the things can actually happen. And of course, like once you have this sort of making the appointment, okay, so you can still cancel the appointment as well. Okay, so that is pretty straightforward. So both patient can do it and then like the scheduler can do it. Interestingly, when you are making the appointment, okay, you have to check the patient record. If the patient is already an old one, okay, so whenever you are making an appointment, so basically like you will be seeing like what was the original record of the patient and then like what else he really needs. Okay, what is his current problem? So that would be a perfect include relationship for this one. Okay, so make the appointment and then like check patient record. They have this sort of include relationship. So during the making appointment, so this check patient record use case will also be executed at a particular place. Okay, so that's about the include relationship. The patient can, of course, like once the appointment is there, so the doctor visit has happened, and then like basically patient can request for the medication, and the doctor can request for the medication. Okay, but again, like the doctor is actually for the request medication. Okay, so which the doctor is doing after this sort of appointment. Okay, so the visit, this request medication still has to basically go through, include this sort of check patient record. The doctor will be checking the patient record and also the patient. Okay, then only we are requesting the medication. Okay, so that is again like an include relationship is there here. Okay, two include relationships in this particular system we have seen. Now comes like say for example the medication has been prescribed and the patient has visited and then like so all the things have happened. Now he has to pay for it. Okay, so a clerk will, I mean, like there will be a patient pay bill use case. Okay. So this pay bill, okay, since the doc he has visited, okay, the doctor has seen him, okay, and now he has to pay for it. Okay, so that means like this is a use case. The pay bill will be a use case which can be accessed by this clerk or the patient. Okay, so both of them can invoke this system. So you have to basically pay for it. But then like there can be extension behaviors for that one. Okay, say for example like when you are paying the bill, okay, so the extension point is like say for example whether the treatment is finished or not. If the treatment there is an extension that more treatment is necessary, you are not going to generate the bill payment immediately, isn't it? So that's why like there can be an extension use case for that one, which is the deferred payment, okay, for a later time if there is more treatment which is to be done. So this is the extension points like which we have discussed with the earlier example as well. Okay, so even here it actually makes sense. Okay, whenever the patient is there, if he needs more treatment, okay, so then you are basically extending the behavior with this sort of deferred payment. Okay, and within this paying the bill, okay, so which the patient has to do, of course, like the system from the clerk actor can also access that one. The paying the bill is like directly you can pay from the money, okay, with the money or with the card. Alternatively, you can actually bill the insurance. That's a generalization relationship you have with this sort of bill insurance. Okay, so either you pay it directly or like you have to bill the insurance. So that the procedure will be a little bit different. So the child use case here is a bill insurance. Okay, so which is a specialized behavior of this paying the bill. Okay, and then like if the patient want to pay the bill but then like he want to pay with the bill insurance, okay, so this use case will replace the pay bill for that particular patient. Okay, this is a perfect use case diagram, okay, with all the features which we have learned as part of the use case as of now. So as far as the references are concerned, now we are in chapter 8 of object-oriented modeling and design with UML. Okay, Michael Blaha and James Rumbaugh. Thank you very much for your attention.